All right, welcome back to Way of the Wrench, and on today's episode of How to Become a Welder, we're going to learn about brazing, and I'm going to give you some knowledge on how to use some basic tools and a machine or two, and we're talking about materials and all kinds of good stuff. So stay tuned, you're not going to want to miss it. Okay, so first up, what's brazing? Well, brazing is the act of joining two metals together with a second type of metal that melts at a much lower temperature. They usually use brass, hence the term brazing. So the definition I just gave you is literally the definition of how a hot glue gun works too, right? If you think about it, you put a little bit of heat through the glue gun and you melt this solid glue stick into a runny glue, put your two things together, and when they cool down, they're stuck together. So really, there must be something more going on here, no? And there is something going on that no one has ever told you in your whole entire life. It's called van der Waals forces. So van der Waals forces is the attraction between two different materials depending on how close they can physically get to each other. And this is all happening on an atomic level. So literally the atoms in this material are attracted to the atoms in this material depending on how close the surfaces can actually get to each other. Now, before you take off thinking that this video has gone off on a completely weird geek out tangent, stay with me. It's gonna make a lot of sense. In just a second, let's go down and I will do a drawing for you. If we have two pieces of metal that we're trying to braze together, or really two pieces of wood that we are trying to glue together in the wood shop, if you were to look at those smooth surfaces underneath a microscope, you'd actually be surprised to see that they're really quite irregular and jagged. And because both of them are like that, they're not really close enough to have that atomic bond through van der Waals forces. Now, when we braze, we are going to melt brass, and the liquid brass is going to go in and fill in all of these little cracks and crevices. And then once the heat goes away, that brass solidifies, goes hard, and then because the brass is so close to the atoms in the materials, we now have that van der Waals force take action, and that is what is holding this together. Okay, that seems kind of crazy. You're telling me that I can just heat up brass and melt it over two pieces of steel and have them stick together? Yes, I am. And I'm also telling you that if you were to heat them up again, you'd have this thing fall apart. Now, I know I just told you that brazing is a lot like hot glue gunning your metal project together, and it sounds really quite weak. However, don't be fooled. Brazing is a very good joining process. It's not as strong as fusion welding, which we'll get into later. However, it is very strong when done properly. So now that we know a little bit more about brazing, why would we ever want to braze our projects? What are the pros? Well, there's actually 4 pros for this welding process, and here they are. All right, number 1. Now, although brazing is considered a permanent joining process, it actually does have the benefit of being able to reheat that brass, getting it to go liquid, and having the parts come apart. That's really quite cool. Now, where would you use this? Well, let's say you've got a part that has to be replaced all the time because it gets dull or broken. Well, you could basically reapply heat, get the brass to go liquid, take the old part off, clean up the area, put the new part back in, the new sharpened cutter, etc., and then re-braze the joint and you're back in business. The second pro to brazing is that we can actually join dissimilar metals together. So now usually you try to weld the same types of metal together, but in this case, because we're kind of gluing them together, we can actually have cast iron and steel, we could have carbide and tool steel, we could have brass and copper, all this kind of dissimilar stuff. We can braze them together. All right, so the third benefit of brazing things together is the fact that because we are not fusion welding, where we would have to melt the actual base materials and get them liquid to go together, we can have a lot less heat. We only have to have enough heat to melt our brazing rod and apply it to the top of the material. So with less heat in our metal projects, we get less warpage, especially when we're talking about thinner stuff. The fourth pro for brazing is the fact that it just looks so cool, right? If you're the artistic type and you're making a cool big metal sculpture and you want to have splashes of gold in your project, then this is where brazing is going to come in handy. It looks really quite cool even without any kind of buffing. Right, as for cons for brazing, there's really not that many. Probably the biggest con would be that this is technically not as strong as fusion welding. However, like I said, it is really quite strong and depending on what you're doing. Now, the other thing that maybe might be a con is that you can't do this with all of the 4 welders. You can only do this with gas welding or TIG because you need to get the heat in there to be able to melt the brazing rod.
Now, one of the things you got to watch when you're doing brazing is you have to plan out when you're going to do your brazing and in what order and how you're going to hold the parts, because I've got one braze joint here. As soon as I put my third part in here and start heating up the second part to get it to bond, I'm actually going to probably reheat this and that's going to fall off.
Now, depending on the materials that you are trying to braze together, you're going to have different requirements of what kind of brazing rods you need. Some materials you won't need any flux and you can just buy a pure bronze or brass brazing rod. But in most cases, you're going to have to pick up one that has a flux coating on it. Now, the flux acts like a cleaning agent and it cleans the base materials and prevents any oxides that would prevent the brass from sticking to the base metals and having a good braze joint. All right, in order for me to show you some brazing here, I have some material to cut up, and I thought what a great time to just talk about the trades for a second. So you are here watching a video on how to become a welder, yet I'm going to show you tools like a steel fabricator would use, and a little bit later you might be doing some precision measurement and using machines like a machinist, and a little bit later after that you might be doing some frame repair or putting in some custom exhaust in an automobile like a mechanic. So it's really important to know that a lot of these skills that you are learning are transferable throughout the trades. We are sharing the same tools and measuring equipment, and the whole idea of using our hands and our eyes and our brains to the ultimate trifecta to become ultimate tradespeople is really key. All right, if you're going to order some steel for home projects or some welding sample material, there are two different choices when you're ordering. So you've got hot rolled and cold rolled steel. Now, cold rolled steel is always going to be way more expensive. It is very precise because it is formed when it is cold under high pressure and rollers to the exact dimensions you order. So if you're trying to make something really finicky and you need it to be exact, order cold rolled and it'll be all nice and clean and ready to weld for you too. However, it is more expensive. Now, if you are just doing welding samples and you just need steel to weld, go for hot rolled steel because it is way cheaper. And the reason why it's cheaper is they don't need the high pressures and rollers. They can literally take the glowing red hot metal and put it through the rollers to the dimensions that you were ordering, except when it cools down, that hot red metal will actually build a scale on it, and it looks like kind of like a black gray coating that's on the outside of the surface of the metal. And the only thing is we have to clean that off before we do any welding so it doesn't affect our welds. So for these samples, I'm going to be using this hot rolled flat bar steel. It's 1 inch wide and 1/8 thick, and I'm going to make 2 pieces 4 inches long. So I'll put it on the end, and what I like to do is make little crow's foot marks. So pull it away at an angle starting from the line at the 4, and then I've got a really accurate point from where I have to cut. Now, when you're putting your material in the vise, it's always a good idea to keep that cut line just to the side of the vise. If you have it hanging out too far, a lot of the work from the file or the hacksaw is going to get turned into vibration rather than the actual work you're trying to get done. All right, some good tips for using a hacksaw properly is whatever hand that you write with is going to be the hand that is going to be pushing the hacksaw and steering it so it's not going crooked. The other hand is going to be a guide, just try to keep it straight. Now, feet placement is also important. You should kind of have a nice wide stance, kind of like you're ready to punch somebody out and get in a good fight. That way you have some stability and you can put a lot of effort into the cutting. Now, if I just start cutting like this, it's going to go all over the place and not where I want it to cut. So a good way of doing this is if you put your finger near the top of the blade, there's actually no teeth and it's not sharp, and you can use that as a rest to guide the saw to get your cut going. Now, find your cut line, put your finger near the top, and I like to start making a cut called a kerf by going backwards. And then once you have a deep enough kerf, then you can go ahead and start cutting. Okay, nice wide stance. Try to use as much of the blade as possible, otherwise you're just wearing out the center of the blade. Plus, you're only doing about 25% of the work. So, full length of the blade. Once you got the hang of it, you really put some pressure in it and go fast. However, when you get to the end of your cut, watch how much pushing you're putting in, because all of a sudden this piece is going to fall off. You're going to end up wrapping your knuckles against the vise. Just like that. So I've got some welding samples cut, but they're not exactly square on the end and there's lots of burrs on them. So I'm gonna clean these up with some files before we move forward. Now, I know what you're thinking, dude, these are just welding samples. Why are you worrying so much? But one of the things I like to talk about this with my students is if you don't ever practice making 100% accuracy layouts and cutting nicely and filing nicely, when are you ever going to learn these skills, right? If you never do it with the welding samples and jump right to your welding project, it's gonna look like garbage because you haven't practiced and honed these skills. So it's just a weld sample, but clean them up, make them look nice. this weld sample material is hot rolled steel and it has that mill scale, and I don't want that to affect my braze joint. So I'm going to be using a wire wheel to clean up wherever I'm wanting to braze. Now today I'm going to be showing you a corner joint, and we have to clean up the mill scale off of the edge and the sides right next to that edge on both pieces. So I'm going to do that right now. All right, some quick safety for wire wheels. Make sure you have safety glasses and a face shield, because these little wires tend to come out randomly and they can get into your eye, into your lip. So make sure you got that on. Don't have any gloves on. Take off any loose dangly clothing so you don't get caught up into the machine. Now, these also have a tendency for grabbing the stuff out of your hands and just chucking it across the shop. So make sure you are not pushing too hard, and I would never have any kind of sheet metal on here. And there's also kind of like a sweet spot for where you should be using it. So I use it from where the center of the axle is to about the bottom area. So this spot right here is okay to do some kind of wire wheeling. Do not use the top surface, because if it catches, it's going to throw it right back at you. Now, it also loves to catch edges. So if I'm going like this all the way to the end, it's going to catch the end of the piece and just fling it out of my hand. So a better way, if I've got to do the whole surface, is start and do half, and then flip it over to do the other side to finish it up. That way you won't catch an edge and have it chucked out of you. As you can see, that wire wheel has done a really good job of cleaning off that mill scale on the sides and on the edge. And that way, when we go to do our brazing, we're going to have a really good solid connection from the braze to the metal, and not this loose mill scale that can come off. Okay, so for welding this kind of thickness material, I don't need a ton of heat, plus we're only brazing. So I've got a number 1, nope, scratch that, I've got a 0 tip in this. So the bigger the number on this welding tip here will be a hotter flame. So this is a 0. Now, before I get going here, I should probably try to clean this up a bit. So you just take the little tip cleaner set, you take the file, clean off the end, make sure there's nothing plugging the hole on the end there. And then find a appropriate size little needle file, basically like a little round file that you can get in there, and take out any debris from that orifice. Make sure that there's nothing that's going to be plugging, not letting the gases flow out properly. Now, if you're doing any gas welding or brazing, you're going to want these fire bricks so that you can weld on top of those. That way you're not putting the heat into the steel table and then accidentally touching the table and getting yourself burned later. So the joint we're going to learn about today is called the corner joint. Now what we're going to do is we're going to take our pieces of metal and lean them against each other so the top edges touch, and it kind of supports a little angle here. And we're going to be welding the top of that seam. Kind of like when you take 2 playing cards and you lean them against each other and they can hold each other up. Now, while you are trying to set this up and in between getting it tacked and held in place, these can be a little difficult to do that with. So what you're going to do is you're going to get yourself a magnet and set it up like this. Now, once you're ready to go, you're going to want to make sure that this thing is exactly even. You don't have one side higher than the other, etc. And that there is no gap between the 2 pieces. Otherwise, you're just going to have the liquid braze flow down in between the 2. Okay, so before I get going on the brazing here, I'm not going to show you the safety and setup for the gas welding or how to get to a neutral flame. There's a great video to be able to watch for that, and I'll put the link above. Now, most of the time when you're doing your brazing, you're going to want to have a neutral flame, but there are some times when a carburizing or feathering flame will actually be better. So one of those times is when you're dealing with copper. The extra carbon that comes out of the acetylene actually helps wash the oxides out of the copper and lets you get a better job done. Plus, it's a lot more gentle of a flame, so you can kind of wash the area to get some really nice capillary action where that liquid brass will just flow into where you need it to. Okay, with a dark tinted lens here, it's a little bit harder to see, so I'm going to talk my way through it. So once you've got your acetylene flame set so that there's no soot, Then you're going to slowly turn your oxygen on, and then watch your second cone come down. And you can actually kind of see the third cone in there, kind of shrouded by the white. So just keep increasing the oxygen. The second cone's coming down. And to get a neutral flame, we go right down so that they meet like that. That's our neutral flame. But we actually want a feathering flame or carburizing flame, so we're going to close the oxygen a little bit and have it just flickering, a little bit of that second cone flickering past the first cone, and that is what we want to use for brazing. Now, there is such a thing called an oxidizing flame. It's when we go back to neutral and we actually go a little bit more with the oxygen and get a sharper, more oxidizing flame. And the other hint is that it sounds really loud. If it sounds really loud to you, then it's probably an oxidizing flame, and it's not what you want for gas welding and brazing. Now, when I'm teaching people to braze, I don't want them to struggle with these things falling apart as they're brazing. They can do that later in life. So what I usually get them to do is I show them how to gas weld tack, and I get them to tack the one corner, make sure these are nice and straight, no gaps in here, take the magnet off, and tack weld the other end. That way this thing isn't going to move and we can just focus on doing really good brazing. So I'm going to do that with you. In a future video, I will actually show you the gas welding process and what I'm doing here. For right now, we are heating up the metal until it gets hot enough that it puddles into one little puddle. Let it cool down, and that'll hold it together while we're doing our brazing. Now, I want to do a good video for you guys all about tack welds and how you can use those for your benefit. So right now I'm just going to do the tacks, but just so you know, when you do a tack, things move around. So you want to take a look at your seams, make sure they're still together, make sure things are not moved on you, and you get it exactly where you want. Now, I don't need the magnet at this point anymore, so instead of damaging the magnet, we can take that off. Take a look at my seam. It looks very good, looks nice and straight, angles exactly how I want it. So I'm going to flip it over and just do a small little gas tack weld to hold this in place on the other side. Now that the ends are lightly tacked in place, we can focus on just doing a really good brazing sample and working on those skills alone and not worrying about this thing falling apart as we're doing it. Now remember, when we're brazing, we don't want to melt the base materials. We just want to get it simply hot enough that we can get the brass to turn into liquid and flow evenly onto the surface. So the indicator of how hot the steel needs to be is the color. Now, when you've got the torch on the steel, it's kind of hard to see what the color is, so you can momentarily take it away and take a look at the steel. And if there's no color, then it's still too cold, keep going. But the very first color you're going to start to see is kind of a dull red glow coming from the steel, and that's about the temperature that you want for the brazing. You can go a little hotter where it starts to turn into a dull kind of orange glow, but if you keep going, it'll start getting really bright, and then the surface will go liquid, and then at that point you're gas welding. Now, remember, you have a kind of stupid gas welding flame here. It doesn't do anything and you can't adjust it on the fly. So you have to control the heat by moving the torch away or putting it back and aiming the heat at the metal. So you can't just leave the torch pointed at the pieces, otherwise it's going to get hotter and hotter and hotter until it starts melting the base metal. So you do have to regulate the heat constantly by moving the torch away and watching how the color changes. If you leave it too far away, it'll get cold too fast. If you don't leave it away enough, it'll start to get too hot and it'll start going into that orange color. So it is all about regulating the heat with the torch. Now, once you have that dull red glow, you're going to put your brazing rod right where you want to apply the brass, and then put the heat, and you'll watch the end of the brazing rod melt, and it'll flow and turn into liquid. And then you got to back off the heat, move the brazing rod over, reapply, and it's just a repeating process while you're regulating the heat. So let's go for it. Okay, we got to get some heat in there. Look for that dull red color.
I'm gonna start right at the very end. Might have to regulate my heat a little bit by pulling the torch away, just because it's right at the end and there's nowhere for that heat to go. Okay, there's my color, I'm ready to go. Place the braze where I want to start. And this is all about regulating the heat. If you leave the torch there too long, then you're going to liquefy your brass. It's going to run all over the place. And it's going to go towards wherever the heat is. That's through that capillary action. If you have any holes, back up. Fix it while you're doing it. And if you don't have it there long enough, then you're also going to get it too cold. If you start noticing that it's not really flowing, and making a nice little hump for you, but it's kind of looking like bird poop sitting up on top, and that's way too cold. So leave it there a little bit longer. And then once you find your groove, you just keep going. Watch what you've laid behind you. Make sure that you're still doing good. And ideally you kind of want the brass to just slightly melt and kind of make a little hump on the top. You don't want it to be flat, and you definitely don't want it going so liquid that you can see the seam in between the two pieces either. It's too hot, and what you'll find there is most of the brass has literally run between the two pieces and gone down underneath, or it's gone down the side, and most likely the side that you favored on when you were pulling your torch away, which for me is the side towards the camera. So we'll see when we're done what it looks like. Now I'm getting near the end here, and as I get near the end, there's nowhere for the heat to kind of dissipate. So the piece is going to get hotter and hotter near the end, so I'm going to have to regulate my torch even more than I have been. Otherwise it's just going to liquefy and make a big mess. And if you got to pause and let it cool down, that's fine. Okay, and I can already see it's a little harder to get that hump. Getting right near the end. Pause for a bit. And make sure you go right to the end. That way you don't have a weak spot in your braze joint. There we go. Now it's really important not to move this while it's still glowing red hot, because there could be some liquid brass here and you might have it fall apart on you. So just let it sit for a couple seconds.
Now, looking at the brazing sample that we just did, these are the things that I look for when I'm checking to see if I have a good braze or not. Now, the first thing is there a hole anywhere in here? Either I went too quick or I just kind of missed a little spot and didn't back up and fill it in as I went. And in this case, there's not a single one, so we've got maximum strength that way. The other thing I look at is at the beginning and at the end, start and stop points. Is there a missed spot, where you didn't actually flow, or you just left the tack, or you just left it cracked on the end in between the two parts, and that's going to make a weak spot going forward. So in this case, I've got enough on both ends, so this is going to be nice and strong. The other thing is, have I added strength to this? So it's not just flush with the top of the steel pieces. I've actually got a little bit of a hump. So I'm adding strength to this joint by doing that, yet it's not so high that it's lumpy and cold and irregular. Now the other thing I'm going to look for brazing is the heat control. So this side is absolutely perfect. We got a little bit of leftover flux that didn't burn off quite enough, but that's okay. It is over top of the edge. And then on this side, where I favored the torch when I was regulating the heat, you can see that it's got a little bit extra on this side, and that's nothing that's going to make it weaker. It's actually probably making it a little bit stronger, but sometimes if you have an excessive amounts, it's just waste and can look bad because it's supposed to be a good cosmetic looking joint too. The other thing we can look for when we're looking at a weld or a brazing joint is to look at the other side and look in between the two pieces and see if we've got full thickness penetration, or in this case, did we get enough capillary action that we actually have brass coming through to the other side? And you can see that we do. We've got a couple spots here where we can see the brass poking through, and that's going to give us our full thickness braze between these two parts. So overall, this is a nice looking braze joint that should have full thickness and strength, and I thought maybe we could actually even test this. Maybe drive it over a car or hit it with a hammer and see what happens.
Okay, that was pretty cool. I've never actually tested a welding sample by driving it over with a vehicle. But let's say that vehicle is 8,000 pounds and one of the wheels is a quarter of it. So 2,000 pounds of force, and it did absolutely nothing to this. And it even did absolutely nothing to the one that I tried to botch and do a horrible job on. I doubt this even has a quarter of the strength as this one, and not a blemish on it. So I figured I'd continue with some little destructive testing here. Got a vise and some hammers. Let's see if we can get these things to break, or maybe even just not break. We'll see. Now, the vise did break this brazing sample as expected because the brazing is not as strong as gas welding sample. You've got a different material there with different tensile strengths, so when you're asking it to do too much, instead of it just stretching like it does with the steel around it, it's not as strong, so it's going to break. Now, kind of interesting, it didn't break right along the center of the brazing bead. It actually broke where it attached to one piece of the metal, and even more interesting is it's broken only on the side where there's a little bit less brazing. So it's quite possible that that side I favored put a little bit extra braze, made that side stronger, and that's why it broke on this side. All right, so I've got another sample set up here, and what I thought I would do is I would show the two most common kind of issues that people have with brazing. First one is going to be going way too cold. They're just melting the brazing rod and dripping it on top of the surface, making bird poops, not getting that base metal hot enough. And then the second one is getting way too much heat, almost like they're melting into the base metal and having the brass liquid run all over the place and make a big mess. So I thought for the first half I would do it too cold, and the last half I would do it way too hot, and then we can take a look at it after. All right, so once again, this first half is going to be too cold, so I'm not even going to get the material hot. I'm just going to start melting the pieces on top. It's very, very common. And then when people are doing it too cold, what often ends up happening is they finally kind of leave the torch a bit too long, and then you start to see it kind of start to melt like it's supposed to, especially near the end where it starts to get hotter. Okay, so that one's too cold. We'll take a look at that after. I'm going to move the magnet. We don't need that magnet there anymore. All right, and now we're gonna go way too hot. I'm actually gonna turn this around. No, I'll leave it. The camera all set up. Okay, now we're gonna go way too hot here. So not only are we gonna get that heat in there, we're gonna get it way past what it should be. That brass is gonna melt, it's gonna oxidize, it's gonna do all kinds of nasty stuff. We may even get some popping here on film. So surface is going liquid already, so this is way too hot for the brazing. And I'm going to not regulate my heat as much. So it's popping like crazy. It's not happy. Should be one good tell. The surface is really runny with brass. It's flowing all over the place. Flux is burning off really quickly too. Lots of good capillary action going on here, but it's probably going all into the inside or down the side.
right, so take a look at this sample that we just did. Remember, this is the too cold side and this is the too hot. So I tried to make it as obvious as possible. Sometimes you have to exaggerate the scenarios to kind of see it a little bit more clear. Now, the side that I got cold on, I actually started right at the very corner. However, I was melting and looping the brazing rod right onto the top. So just from putting it in the water to chill the sample down, 2 or 3 of them actually just fell right off. So very little bonding to those surfaces. You can also tell it's really cold because there's a lot of this green leftover flux that didn't actually get burnt off and didn't actually get activated and start cleaning the surface. Now you can look at it, it looks very lumpy, like a bird poop. Should be nice and smooth, have a nice slight hump to it, or at least be flat. And in this case, it's just big bulgy pieces of poop. So really obvious, this is really quite cold. Now when we look at the other side that got too hot, first off, I can see burnt oxides all over the place. While I was doing it, the flux was burning off like crazy. And there is no hump. In fact, I can see the seam between the 2 pieces, so there's a loss of strength in there because there's just literally no brass. And none of the flux is available and left. It's all just been burnt off and burnt away, and you can see all the extra oxides. And if I flip this over, you can see we actually got some good capillary action where the heat was down in here, and so it sucked that brass right through the crack into the backside, but still not a lot of strength because this isn't filled up, and there's a crease there that we can still see, obviously. So too cold, too hot. Hopefully this will help you guys try to troubleshoot your brazing samples as you go forward and allow you to get a better weld.
But that's a wrap on another video from Way of the Wrench and on how to become a welder, this time on the wonderful world of brazing. If you have any questions or concerns, put them down in the comments below and I'll get back to you as soon as possible. And if you haven't already, why don't you follow us on Instagram, Way of the Wrench. All that's left now is for you to take this information and go and practice and practice, practice until you can absolutely nail that brazing sample, and then you get to start figuring out what kind of project you can put together with your newfound skills. So, till next time, cheers.